Hello everyone. The learning outcome for today's video lecture are electrochemical series. We are going to talk about the positive ions and the negative ions. How are they arranged in the form of a series so that we can predict whether they are going to go to the electrode and get discharged. Means this electrochemical series is a range of ions in which the ions are arranged according to their ability to go to the electrode and get discharged. So that is all I'm going to explain under this outcome. And then electrolysis of the aqueous solution of ionic compounds. In my previous video lecture, I have explained that how the ionic compounds in the molten form when they undergo electrolysis, what are the products that are found. We discussed some examples. And even in today's lecture, I'm going to explain how this electrolysis of the aqueous solution of the ionic compound is different from the molten. And I'll quote some example along with the explanation. So let's go. As you can see on the slide, the electrochemical series is a series of the ions in which cations and anions are arranged separately according to their ease of getting discharged to the electrode. In the reactivity series, we have already discussed that the metals are arranged according to their ability to form compound or their reactivity. So the ions are the same, but the metal ions are the same, as we know that the metals form the positive ions. So cation series is comprising of the same metals, and in anions we are going to see about the ability of fluoride, sulfate, nitrate, chloride, bromide, iodide and hydroxide to get discharged. As you can see in the arrowhead is going downward. That means that coming down on the electrochemical series, the ions are discharged with more ability or with ease. So if we are coming down, it means they do not like to stay in the ionic form, but they readily want to take the electron and get discharged or become neutral. So if we are comparing, I'm just quoting an example to make it more clear. I'm quoting an example of sodium and hydrogen. If we are having a compound, say sodium chloride, that's what I'm going to explain further. Sodium chloride, we have made its aqueous solution, like we have dissolved sodium in water and we have made a solution, aqueous solution of sodium chloride. So when we are going to carry out the electrolysis of that aqueous sodium chloride solution, we know that the sodium ions are present as well as hydrogen ions are present. So there is going to be a competition between these two positive ions. So hydrogen, as it is present below the electrochemical series, it has ease of getting discharged. So this would love to go to the electrode. It will win the competition with sodium and will quickly take the electron at the negative electrode and become neutral. Same is the case with the anions, where if the competition is between those ions, anions which are present at the top and the one which is present at the bottom, then what happens? What we can expect? We'll expect that the one which are present at the bottom of the electrochemical series of anion will go and get discharged. So we are going to apply this to our further examples. So let's go. First of all, we are going to discuss the electrolysis of the aqueous solution of sodium chloride. As I have already explained that in the aqueous solution means some ionic compound is dissolved in water. So what's happening there then? Water will ionize to form positive and the negative ion, hydrogen and hydroxyl ion. Let's see their position in the electrochemical series. Hydrogen is present here and hydroxide is present here. So, and sodium chloride will ionize to form sodium ion and chloride ion. So their position in the reactivity series is sodium is at the top, so it's very difficult for it to get discharged, and chloride is present here somewhere close to hydroxide, but as this is aqueous solution, so chloride ions are less in number, hydroxide ions are more in number, so hydroxide ion will win the competition. And what will happen? The hydrogen ions, among these two positive ions, the hydrogen ions will go and get discharged because in the electrochemical series, this hydrogen is present below sodium, quite below in the electrochemical series. So the ease of discharging hydrogen ion is much more than sodium ion. So this will go to the electrode and get discharged. And among the anions, here hydroxyl ions and chloride ions. Hydroxyl ions will go and get discharged. So what is going to happen when the hydrogen from among the positive ions and the hydroxide among the negative ions will go and get discharged, and the sodium chloride solution will become more concentrated. So let's see what happens when we are taking the concentrated solution of sodium chloride. The concentrated solution of sodium chloride is called as brine. In this case, the concentration of sodium and chloride ion is more as compared to the hydrogen and hydroxyl ion. So looking at the reactivity series, electrochemical series, the distance between these two positive ions is quite a lot. So hydrogen will still prefer to go and get discharged, though its concentration is less. But in case of chloride and hydroxyl ions, since chloride ions are more in concentration, so even though they are present above the electrochemical series, they will have to go to the electrode and get discharged. So that's why you see the bubbles of gases here at both the electrodes. At the positive electrode, the chloride ions will come and get discharged, and chlorine gas will be formed. And at the negative electrode, the positive hydrogen ions will come and get discharged and form hydrogen gas. So if you want to look at the application or the uses of the chlorine gas and hydrogen gas, you can look from here and note it down, because these are the questions they usually ask in the form of the products and the uses of the products. So chlorine gas is used to kill germs and bacteria and to make acids and bleaches and plastics, and hydrogen gas is used in manufacturing of ammonia and margarine. So in the organic, we usually study this, the formation of margarine. And what will happen to the remaining solution? When hydrogen and chloride ion will go to the respective electrodes and get discharged, then in the solution, sodium and hydroxide ions will stay. So they are going to react with each other and form sodium hydroxide, so the solution become alkaline. So this is another question they can ask in the past papers. Looking at another example, that is the electrolysis of the aqueous copper sulfate solution. The ions formed are again the 4 types of ions. This is the key. You can look here. These are the sulfate ions, hydrogen ion, copper and hydroxide ion. These red color are electrons, and these circles are representing us the bubbles of hydrogen gas, the gas which is produced at anode. Let's see which gas is going to produce. Among these 4 type of ions, the 2 ions are the positive and the 2 ions are the negative ions. Copper and hydrogen ion are the positive ion. Looking at the electrochemical series, see, hydrogen is present here and copper is present here. So it means copper is present below hydrogen. So it means the ease of discharge of copper is better than that of hydrogen. So copper will go and get discharged at the negative electrode. Among the positive, again hydroxide ions will go, because sulfate is present high above the electrochemical series. So hydroxide ions are going to get discharged and producing oxygen gas. So you are going to write the equation. Hydroxide ions will lose the electron, means they get oxidized at anode, which is a positive terminal. Oxygen gas and water is produced. These are the bubbles of the oxygen gas. So at anode, oxygen is produced. So if they are asking you the product of the electrolysis of copper sulfate solution, then of course oxygen you are going to write. And what observation? If they ask you what will you observe, then of course the bubbles of the gas, colorless gas, you are going to write. And what happens at cathode, which is the negative terminal? Electrons are coming this way, and then what's happening? The electrode, cathode, is going to gain the electron which are coming through the wire, and the copper will get discharged. And as this is present below the hydrogen in the electrochemical series, so it is gaining the electron. Gain of electron is reduction, so copper matter is getting reduced and pure copper deposited at the cathode. So this method is also used in electroplating process. I'm going to explain electroplating in some other video. So what are the products formed? The ions formed are for, okay, let's first discuss the ions which will be formed, and then what will be the product. Ions formed are 2 types of anions, hydroxyl and sulfate ions, and 2 types of cation, hydrogen and copper. and which are going to get discharged? Those which are present below the electrochemical series, so copper and hydroxyl ions. So they will go and get discharged. From hydroxyl ions, oxygen gas will be produced, and from copper ions, copper metal is going to get reduced and separated. Discussing another example, as I have already explained that if you are taking concentrated solution of sodium chloride, then hydrogen and chlorine is going to get discharged. The equation, I have added this slide to explain how you are going to write the equation. Hydrogen going to at the cathode will gain electron and form hydrogen gas, and chloride ion will lose electron at the anode and will form chlorine gas. So other ions will be present here at the bottom. So hydrogen is going to be used at cathode and chlorine gas will be used at anode, and the rest of the solution will become more alkaline. Why it become alkaline? Now you know that both the sodium and hydroxide ions will react together to produce sodium hydroxide. So that was the electrolysis of the concentrated sodium chloride. Now let's see another example. Potassium chloride, aqueous. So potassium, rather than looking at the slide, I'll go back to the electrochemical series and let's predict ourselves what's going to happen. Aqueous potassium chloride. Aqueous means water molecules are there, so K positive and H positive ions are produced. That's very obvious looking at the electrochemical series that H positive ions will go and get discharged producing hydrogen gas, and among chlorine and hydroxyl ions will go and produce oxygen gas. So let's go and see whether we are right or wrong. So electrolysis of the aqueous solution of potassium chloride result in the production of hydrogen gas at one electrode. Yes, at cathode, we are right. So solution becomes basic near this electrode. Okay, the reduction half reaction occurs at this electrode. Of course, we know that whenever electrolysis is occurring, at each electrode half cell reaction is occurring, and at the other electrode the other half cell is occurring. So this is not going to be included in your syllabus. Just you need to remember the products that at positive terminal oxygen gas, and at negative terminal hydrogen gas is produced, and that is all. Now this is the summary of and you can add these two. You can predict, do it by yourself or as a practice, that aqueous nitric acid if you are using, then of course H positive and OH negative and NO3 negative ions are produced. NO3 is present high above in the electrochemical series, so H positive and OH ion will get discharged at both electrodes, like at their respective electrodes. And this too we have already done. So this was all about for today. We have done enough examples. I guess this is quite clear to you. Let's review. Okay, in the learning outcomes, we discussed electrochemical series of ions, where we discussed the positive ions which are present high above in the electrochemical series are much more reactive and much more difficult to discharge. So the one which are present at the bottom are less reactive and easy to discharge. And electrolysis of aqueous solution of ionic compounds, and among that we discussed the examples of dilute and aqueous solution of sodium chloride, concentrated aqueous solution of sodium chloride, aqueous solution of dilute of course copper sulfate, and potassium chloride. So these were the examples. I hope this lesson is going to help you in understanding electrolysis of the aqueous solutions of ionic compound. If you have any queries, you can write in the comment section. I'll see you in the next video. Thank you so much. God bless you. Take care.